अच्छा चले ठीक है अभी Iza, can you hear me?
Yes, sir.
अच्छा चले ठीक है अभी Iza, can you hear me?
Yes, I can hear you.
Just 1 second. अच्छा चलो ठीक है ये S18 QP41 यहाँ से हम स्टार्ट कर लेते हैं इसको बस कंप्लीट करना था so the question the first one ठीक है the first question is के right ये मैं select कर लूँ एक second अच्छा write an equation for the reaction of sodium with oxygen forming sodium oxide so that's okay इसमें कुछ भी नहीं है just 1 second it's just hold on 1 second just 1 second hold on पेन के issues बने हुए हैं, वो sort out हो जाए So just 1 second इसको मैं दूसरे उस पे खोल रहा हूँ ठीक है my pen has stopped working so तो sideways करना पड़ेगा. The first one, ठीक है कि equation बनानी है कि it's sodium with oxygen, sodium oxide, ठीक है, that's not an issue. Why is sodium oxide having a high melting point? तो उसके अंदर ये 1 का part B, ठीक है. Why is sodium oxide having a high melting point? तो आप उसमें बताओगे कि sodium oxide का it has a giant ionic lattice because it's an ionic compound. और उसके अंदर बताओगे कि positive and negative ions, uh, it's a regular arrangement of positive and negative ions. And there's strong electrostatic forces, arrangement of positive and negative ions, and they're going to have strong electrostatic force of attraction between them. ठीक है, that's the first part. फिर वो कह रहे हैं कि it was a 2 mark question. Then part C के अंदर वो कह रहे हैं कि sodium oxide reacts with water to form an alkaline solution. Explain why the solution obtained is alkaline. You should use Bronsted-Lowry theory of acids and bases in your answer. So why is it alkaline? तो आप बताओगे कि the first thing that you're going to talk, और ये कौन सा part है? C part 1. उसके अंदर सबसे पहले तो equation, you'll give the equation which is कि sodium oxide when it reacts with water, it's going to produce NaOH. Now we know that NaOH is a base. ठीक है, we obviously know that कि NaOH is a base. लेकिन उससे क्या है कि if you go back to the question, he's specifically saying कि use Bronsted-Lowry acid base theory in this. वो use करके आपने बताना है. तो bring that theory in, which is that you're going to then state that OH ions are Bronsted-Lowry basic bases. Bronsted-Lowry bases. Why are they bases? Because they accept H plus 1 ions. And then you should give an equation where they're accepting H plus 1 ions to form water. So they are going to remove H plus 1 ions, or they're going to accept H plus 1 ions. So you have to bring this in to complete the answer. ठीक है, उसकी थोड़ी बहुत डेफिनेशन वगैरह बीच में देनी थी. अब फिर वो कह रहे हैं कि निकालो pH, निकालो, calculate the pH of 3.1 grams of sodium oxide when it's added to 400 cm cube of water. So it's 3.1 grams and 400 cm cube solution बन रहा है इनमें. So we're going to take this equation, और इस equation को पहले तो नीचे ले आते हैं. अच्छा, we're going to take this equation, ये वाली, and it's not balanced, so balance it first. सबसे पहले देखो कि how much sodium oxide was he actually 3.1 grams. So you can find the moles of sodium oxide. So it's 3.1 grams divided by the MR. You'll find the moles. The MR of this thing is 2 sodiums. That's 46 plus 16. That's should be 62. 23 plus 23. So that is 46 plus 16. That's 62. So इसके moles calculate कर लो. How many moles of sodium oxide do you have? So if you do that, that's 3.1 divided by 62. किसी पास है calculator?
0.046 or
अच्छा,
47.
तो कितना 0.04?
7.
Need 3 significant figures. The 46, what's the third one?
It will be 0.0469 into 47 नहीं हो जाएगा.
नहीं, 9 के बाद क्या है?
And 6.
हाँ ठीक है, फिर वो 70 हो जाएगा. अच्छा, so you have these many moles. इसको double कर लो, you'll find the moles of NaOH. Basically, you'll find the moles of OH ions. So how many moles is that? कि इसको अगर double करें, that would be 0.094. ठीक है, इतने मोल्स हो जाएंगे. ये OH ions के moles हैं. And then you have to find the pH. Now remember, there are two ways of finding pH. One is you find the concentration of H plus one using this. Uh, क्योंकि there are two ways. One is कि you should know कि the H plus one concentration and the OH ion concentration at room temperature, their product is always Kw, which is 1 times 10 power minus 14. ठीक है? Either you can bring Kw in and you can find the concentration of H plus one ions. So it's going to be take OH ions to the other side. So 1 times 10 power minus 4 mole per dm cube. अच्छा sorry, इससे पहले you have to find the concentration because you're not going to use इस step से पहले there should be another step which is find the concentration क्योंकि he was asking for he had stated the volume. Concentration is moles over volume. So we have the volume which was 400 cm cube, which is 0.4 decimeter cube. So how much concentration do we get?
2.35.
Okay, so that's coming out to be 2.35 mole per dm cube. So that's our concentration of OH ions, uh, which is TK, which is kind of very high. But so you can bring in Kw, and using Kw you can find the concentration of H plus ions. The 1 times 10 power minus 4. TK, what you do is you uh, get OH ions to the other side. So using this, you can find the concentration of H plus ions. So it's going to be 1 times 10 power minus 14. And the whole thing would be divided by 2.35 mole per dm cube. तो इसकी क्या वैल्यू आ रही है हमारे पास?
4.25 into 10 raised to power minus 15.
अच्छा नहीं, एक हमने ना मिस्टेक की है कैलकुलेशन के अंदर. वो ये थी कि देयर वाज अ जीरो ओवर हियर एज वेल. ये 0.0940 था बिकॉज इट वाज 0.0470. तो ये एक डेसिमल पीछे होगा. ठीक है, दिस डेसिमल वुड एक्चुअली बी 0.235. और इसकी कॉन्सेंट्रेशन फिर वो कर लो, इंस्टेड डिवाइड बाय 0.235
4.25 into 10 raised to power minus 14.
minus 14. So now you can find pH. pH would be minus log of H plus 1.
1.
बता रहे exactly 1?
Yes, exactly.
नहीं, it can't be 1. I mean, इसका pH कैलकुलेट करना है. Take the negative log of this. Minus 14 है. Let me try this. This is log of 4.25 or minus 14. I'm getting 13.37 or 13.4.
Calculator issue था.
So I'm getting 13.4. That's the pH I'm getting. ठीक है. Remember how to use your calculator properly. Negative log, how to put log. ठीक है, सारा be very good with it. So it's coming out to be 13.4, and that's your pH. Now the other way of doing this is okay, the two ways of finding H plus one if you're given OH ions. One is Kw, which is H plus one concentration into OH ion concentration. That's one way, and that's equal to always 1 times 10 power minus 14, especially when it's under standard conditions. The other one is कि इसी की दूसरी form होती है, which is कि pH plus POH is equal to 14. इसके अंदर बस आपने log लिया भाई. You take the negative log of this. So there's this second identity which can also be used. So the other way you could have solved this was कि अगर OH ion की concentration, you've gotten the OH ion concentration. So what you could have done was कि you could have taken POH, a negative log of OH, और फिर 14 से you could have subtracted it. So that's the other way of solving this question. अच्छा फिर next one. Now you have to draw the bond neighbor cycle. ठीक है, electron affinities are given, atomization is given, and you have to calculate the enthalpy, lattice enthalpy of sodium oxide. So how do you construct the bond neighbor cycle for sodium oxide? The way you're going to do that is you can start off with enthalpy of formation of sodium oxide. So let's first construct the bond neighbor cycle. Enthalpy of formation is that elements they combine and they combine to form 1 mole of substance, which in this case is sodium oxide. तो ये बन गया sodium oxide, and you need to balance this equation. So there's going to be half O2 and there's going to be 2 sodiums. And this is enthalpy change of formation. And this is a solid. And this is a solid and this is a gas. Bond neighbor cycle में what you do is you find another path. You build or create another path uh, to go from the elements to the substance. So you're going to try and figure out this other path. Now the way to do that is first atomize the substance, break the elements into atoms. So for that you're going to do is that you're going to there's going to be enthalpy of atomization of sodium. Sodium atoms or metallic sodium would turn into gaseous sodium atoms. और फिर वो oxygen के bonds ना in O2 molecules, they need to be broken. And if they're broken, so you get an oxygen gaseous atom. So two things are going to happen at this point. One would be the enthalpy of atomization of sodium, but that's going to be multiplied by 2. Why? Because enthalpy change of atomization is for 1 sodium, not 2 sodiums. And the other thing is you're going to break the bonds over here of O2 molecules, but half of them, okay, since it's half moles of O2, so you're going to break half moles of O double bond O. And all of this would be endothermic. Why? Because you're breaking the bonds. So once the bonds are broken, the next step is going to be you're going to ionize the substances. So you want sodium to lose electrons, become Na plus 1, and you want oxygen to gain the 2 electrons to form O minus 2. Now, this is the ionization step once the atoms are formed. Now, to ionize the substance, and remember, I'm combining 2 steps together. Varna, usually in bond neighbor cycle, you first ionize sodium, then you ionize oxygen. Okay? I'm doing it together because he didn't ask me to draw the bond neighbor cycle completely. I said now in this case, it's going to be the first ionization energy of sodium. And where do you get that? You get it from the data booklet, and it's going to be twice that. Why? Because there are 2 sodiums. Or oxygen ki electron affinity. It's going to be the first. It's going to be the electron affinity of oxygen plus the electron affinity of oxygen minus 1. You want oxygen to gain 2 electrons. So pehle the oxygen atom would gain electron, and then when it becomes minus 1, then the oxygen ion would gain electron. And once that happens, though, the last step is the lattice energy, which is that. So the last step is lattice energy, which is always exothermic. Okay, so you're going to have an exothermic lattice energy. Uh, the only thing left now is we're going to put in the values. ताकि, the values are given. Some of the values are given. Enthalpy of formation is given as minus 416. I said, remember, usne, nowhere did he say you have to draw the bond neighbor cycle. Okay, so uh, तो इसलिए if they're not asking you to draw the Bondable cycle, you can sort of combine steps. कि atomize करना है, ionize करना है, and when you have to get the ions together to form the ionic lattice. Now, enthalpy of formation of sodium oxide is minus 416. Okay, you have to be very careful with the moles. So this one is minus 416, and the signs as well. फिर आपके पास you have उसके बाद क्या करना है? Atomize करना है सोडियम को. That's given. How do you atomize sodium? That's 109. So write 109 over here, multiplied by 2. और फिर ऑक्सीजन ऑक्सीजन को तोड़ना भी है, बॉन्ड तोड़ना है, ठीक है. That value is given in the data booklet. That's 496 into half. And then you have to look at the electron affinity of oxygen and oxygen minus 1. That's also provided over here, which is minus 142. Or electron affinity, remember, the first one is always exothermic. Why? Because a neutral atom which likes to gain electrons, it will do the work on its own. It doesn't need energy from outside. Like if a fluorine atom wants to gain electrons, it will attract the electron itself. It's going to do the work itself. But gaining the second electron is difficult. Okay, when you're trying to gain the second electron or the third electron, the electron affinities become positive. Why? Because जो ion होता है वो that is now already negative. It's very hard for a negative ion to gain electrons. So it's easy for the first electron to be gained. Okay, when you're gaining the first electron, the atom is neutral. But it becomes very difficult when you're trying to gain an electron when you're negatively charged. So the first is always negative, the rest are all positive. So minus 142, the next one is 844. तो वो यहाँ पे लिख लेते हैं minus 142 and it is 844. ये दोनों values भी आ गई. The only value missing is the first ionization energy of sodium, which you can get it from the data booklet. So open the data booklet, and in the first few pages there is sodium over here. So this is 494, and this is the second one is 4560. And remember, a lot of people actually, it's surprising, but a lot of people actually take this uh, as the first ionization energy. And a lot of people, when they're trying to do this quickly, they make this mistake. Remember, ये जो पहला वाला number है, that's the proton number. ठीक है, read the column first very carefully. Don't make silly mistakes. So the reason I'm telling you this is because this happens very often. ठीक है, a lot of people, they just take 11 and 494. ठीक है, it's 494 and 4560. But we're looking at the first one, which is 494. So it would be 494 and times 2. And this is also going to be plus. So all your values are there except for this last one. Now Hess law states that one path is equal to the other path. So this is one path, and this entire thing is your other path. Remember to draw the Bondable cycle because otherwise you won't be able to figure out the moles in this. So minus 416 is basically equal to this entire other path, which is plus 109 into 2. Then it's 496 into half. उसके बाद के it's minus 142. Then you have plus 844. Then you are ionizing sodium, which is plus 494 times 2. And at the end, there is minus lattice enthalpy or lattice energy. Okay, it's and we're not going to put the minus sign over here, but we ignore the minus sign. You put the minus sign if the path is wrong. It is exothermic, but by definition, this is the lattice energy. So the value is going to come out to be negative on its own. You don't have to put the negative sign over there. Uh, because the path is correct, gaseous ions forming an ionic lattice, that is lattice energy. So I'm just going to take it as plus lattice energy. The value itself is going to come out to be negative. तो इसको बस solve करना है and you'll get your answer. तो अगर इसको कोई if somebody can try and solve this very quickly, क्या value आ रही है? Sarah, do you have a calculator? Isa? एक second. Minus 416 minus into 0.5 minus minus 142. Reason you should solve this इसको यहाँ पे मतलब practice में ना you always solve try and
minus
always
2572.
कितना आ रहा है?
Minus 2572.
2572. अच्छा even practice के अंदर ना always try and solve this. मतलब खाली की क्वेश्चन हो गया ठीक है उस पे ना छोड़ देना क्योंकि ज्यादा मसले कैलकुलेटर के ऊपर आते हैं. Even solving this people make a lot of mistakes on your calculator. जब तक वो प्रैक्टिस नहीं करोगे तो कैलकुलेटर के ऊपर सिली मिस्टेक्स होती रहेंगी. ठीक है और खास तौर पे चेक करके हमेशा हमेशा ऑलवेज ट्राई एंड सॉल्व दिस. ठीक है जस्ट डोंट सॉल्व हाफ अ क्वेश्चन, do it completely to avoid silly mistakes on the calculator. So next is this thing. We found the lattice enthalpy. Now you're saying state how the lattice enthalpy of Na2S differs from Na2O. Indicate this by placing a tick in your answer. तो उसी वे बोर्ड पे चला जाए. So Na2O and Na2S. इन दोनों का ना you have to do a comparison. So Na2O. अब इसके अंदर clearly lattice energy of Na2O is going to be higher. Why? Because it has a stronger lattice. So can anyone explain why it has a stronger lattice? What's going to be the reason for that? क्या होगा anyone? Lattice की strength किस पे depend करती है? I mean, like sodium ions and oxygen ions are attracted to each other. The lattice strength depends on two things. One is the charge.
Radius?
Yes, and the other one is the radius. Charge over radius. It depends on the charge density. Okay? So the first thing is if the charge is greater, then obviously the lattice is going to be stronger. But over here, the charge is not a factor because both of them, they have exactly the same charges. Sodium is plus one over here as well. O is -2, S is -2 as well. So the charge is not the factor. The second factor is the radius. Smaller ions, they have stronger lattices. So oxygen is smaller than sulfur. So smaller ions are going to have a stronger lattice. So jitna small ion hoga and the greater the charge, the stronger the lattice. It depends on the charge density. So you're going to explain. So charge is not going to be the factor over here. When you try to explain this, एक तो ये लिखते ना कि in the lattice enthalpy is, I mean, this is going to be the correct option. और उसके बाद अच्छा उसके बाद जो option explanation होगी, that would be you're going to comment on the ionic radius of oxygen and sulfur. You're going to state that oxygen has a smaller ionic radius. The charge is not going to be a factor in this particular case. अच्छा फिर next one, define the term rate of reaction. How do you define the term rate of reaction? It's the change of concentration with respect to time. ठीक है, that is rate of reaction. And it could be the change of concentration of a reactant or a product. with respect to time. Identify a change in the reaction mixture that would enable the rate of this reaction to be studied. तो वो खैर concentration इधर हम we can write the concentration. What उससे क्या change in the reaction that would enable the rate of this reaction to be studied. What other change could be studied? I mean, lots of changes can happen in this reaction, but there's a specific change that might be happening over here. That if you look over here, the amount of gas would be decreasing because over here on the left side, the volume of gas is more, and on the right side, the volume of gas is less. So that's another change that you could measure. Uh, and if the reaction is happening very fast, the change would be happening very fast. Four molecules would be changing into three molecules very, very quickly. So the volume of gas would be changing. So a change that you could study is the volume of gas in this particular case. Then you have they've given you a rate equation and they've given you the orders of the equation as well, order of the reactants. Okay, for H2 it's one. That indicates that the order is one, which means that it's directly proportional. That if you increase H2 concentration, the rate would also increase proportionally. And for NO, the order is two, which means that changing NO's concentration, if you double it, it's going to become quadruple. It's going to become four times. If you triple it, it's going to become nine times. As I use the data and the rate equation to calculate a value for the rate constant. To calculate this, just substitute these values over here, and you'll get the K, and you have to find the units of K. So let me just 1 second copy this. As a rate is equal to K over NO concentration squared and H2 concentration power 1. So I'm going to input the values. Rate is 1.27 times 10 power minus 3. And it's going to be divided by NO concentration squared. So NO concentration squared is 2.5. 2.5 times 10 power minus 3. Okay, this is where I'm. So it's 2.5 times 10 power minus 3 squared and divided by H2 concentration. I mean, if you want to find K, H2 concentration is going to be divided 2.5. That's also 2.5 times 10 power minus 3. So that is your K. Again, don't leave it here. Try and find the value. Use brackets in your calculators properly. When you try to do this, make sure clearly tell your calculator what's being divided. It's not an easy calculation to actually perform on a calculator. Can somebody tell me what the value is? किसी ने किया अभी तक?
1.2 into 10 raised to power 4. 8.1. 8.1
अच्छा, it's 8.1, three significant figures. ठीक है, क्या होगा?
into 10 raised to power 4. 8.12
अच्छा, into 10 per minus 4.
into 4. नहीं missing.
अच्छा, plus 4. ठीक है. इसका वैसे वो let me simultaneously open the अच्छा उसका भी देख लेते हैं हमारा एग्जैक्ट ठीक है वो हमारा एग्जैक्ट आया था अच्छा so this one is 8.12 ठीक है well again I think you didn't round the वो three significant वाला part जो है ना that wasn't rounded properly probably 8.13 होगा उसको चेक कर लेना I said then the units. Where's the paper? I said then the units. Units किस तरह होंगे कि remember rate का unit क्या होता है? It's mole per dm cube per second. ठीक है, so it's going to be mole per dm cube per second. So take mole per dm cube as x per second and divide by NO concentration squared. ठीक है, this one NO concentration squared, that's x squared into H2 concentration. तो वो यहाँ पे जाके divide हो जाएगा. That's going to be x. So it's going to come out to be x to the power minus 2 s minus 1 और फिर इसमें मोल पर डीम क्यूब सब्स्टिट्यूट कर लो तो that would give you mole minus 2 and dm is 6 and s is minus 1. And a lot of people actually forget this s. Remember, this is rate is mole per dm cube per second. A lot of people make this mistake. So next is state the order of reaction with respect to NO and H2 and overall order of the reaction. पता नहीं क्यों वो पूछ रहा है कि he already gave them. तो NO2 लिखा हुआ था, H2 1 था, and the overall order is 3. Now the reaction is believed to proceed in 3 steps. And you have to figure out which one of these 3 steps is the slow step or rate determining step. Either copy kar le. Achha, so it's believed to be following these 3 steps. And the order, remember, is 2. एक second इसको. So the order is 2 with respect to NO. And with respect to H2, the order is 1. Okay, that's the information that's provided. Now, how do you figure out the slow step? एक तो trial and error use करो कि trial and error में if this one is the slow step, let's assume that the first one is the slow step. So if it's a slow step, so what would that give you? What information would that give you? Remember, the rate of the reaction only depends on the slow step. It does not depend on the fast step. क्योंकि fast को जितना मर्जी fast कर लो, the rate of the reaction would not speed up. कि मतलब slow step 50 seconds ले रहा है, fast वाला 1 second ले रहा है, तो fast वाले को you further speed it up, it's not going to make a difference. So rate depends on the slow step. So again, if the first one is the slow step, the rate would only depend on these 2 things. So rate would be dependent on NO's concentration squared. Okay, that would be your rate equation, which is not true because reaction उसने जो दी हुई थी, he told us that it was also dependent on H2 concentration. So that's not true. तो इसका मतलब है कि that means that the first one is probably not the slow step. So we're going to second पे आ जाओ. Let's assume that the second one is your slow step. So the rate of the reaction would depend on these 2 things. So that would indicate that the rate depends on H2 concentration and N2O2 concentration. So it depends on these 2. Assuming that the second one is the slow step. Now, if you look at the second reaction, you would notice that N2O2 is not a reactant. N2O2 is an intermediate, and that intermediate was produced in the previous step. And that intermediate is dependent on NO's concentration. तो इसका मतलब है यानी if we say that the rate depends on N2O2, what we basically mean is that the rate indirectly depends on the concentration of NO. Because NO की concentration high होगी तो फिर the N2O2 concentration is going to be high as well. So you're going to get rid of N2O2 in the rate equation and replace it with NO. And because it's 2 of them, तो squared हो जाएगा, ठीक है? Because N2O2 is dependent on NO's concentration but power 2. And that exactly gives us the right rate equation. ठीक है? That gives us the right rate equation. जिसका मतलब है the second step was the one that was the slowest. ठीक है? And that's how you're going to और फिर उसने वही कहा कि उसको explain भी करो. So explanation में what you're going to write is that the rate is dependent on H2 and it's dependent on NO concentration and it's order 2 with respect to NO. तो explanation हम देख लेते हैं how did he explain this part. कि उसने कहा कि the total of steps 1 and 2 the components of the components of 2 it's dependent on 2 NO and 1 H2. ठीक है तो उसने उसी को वर्ड्स के अंदर आप एक्सप्लेन कर दो जो भी हमने किया कि यू गोना राइट कि इसी को बल्कि एग्जैक्टली एक्सप्लेन कर दो कि आप शो करो कि जी पहली स्टेटमेंट आप लिखोगे रेट इज डिपेंडेंट ऑन N2O2 concentration and H2 concentration and then tell them that N2O2 was made in the previous step and it is dependent on NO's concentration squared. So hence rate would be dependent on these three overall. And that is why step 2 is the rate determining slow step. ये clear है सारों को? Sara, is this clear?
Yes.
Is that? ठीक है. And we can also, although it's not required, but we can also test out what if step 3 was the slowest. If step 3 was the slowest, then what would be your rate equation? So it would be dependent on these two things. If step 3 is the slowest, then the rate of the reaction would be dependent on N2O concentration, and it would be dependent on H2 concentration. But again, N2O was made in the previous step. तो इसका मतलब है N2O itself is dependent on these two things. So you're going to remove N2O from the rate equation and you're going to substitute it with H2 concentration and N2O2 concentration. But then you realize that if we say that rate is dependent on N2O2 concentration, we realize that N2O2 concentration itself is dependent on these two. So it's dependent on two NOs. So it's dependent on the NO concentration and the NO concentration. दो दफा NO concentration आ जाएगी. And now when you sum this up, all of this would come out to be it's going to be H2 order 2 and it's going to be NO which would also be order 2. Okay, if the step 3 is the slowest step. The rate of reaction would be dependent on both and both of them are going to have order 2. So then the next one. A third experiment is performed under different conditions. Small amount of H2 of concentration 0.02 mole per dm cube is mixed with a large excess of NO. So remember whenever he says that there's a large excess of NO, so that automatically assumes कि just a second. So that automatically assumes कि NO concentration is a constant. ठीक है, so whenever you have a large excess of NO, so its concentration becomes constant. The concentration of H2 is found to have a constant half-life of 2 seconds under the conditions. Define the term half-life. Half-life क्या होती है? Is the time taken for the concentration to decrease by half. और से कहा है कि 6 seconds है half-life. नहीं, sorry. It had a constant half-life of 2 seconds. तो इसके ऊपर plot करना है. तो 2 seconds के बाद your starting concentration was 0.02 mole per dm cube, which is given over here. So every 2 seconds, the concentration of H2 is going to decrease by half. So this is your starting point. I can't really write on this at the moment. This is your starting point. 2 seconds बाद, the concentration of it is going to decrease by half. Next 2 seconds, it's going to decrease by half again. So it's going to be this point. Next 2 seconds, it's going to be decreasing by half again. So it's तो वो curve बनती जाएगी, ठीक है? So it's going to be a curve that would pass through this. And that's constant half-life. Remember, half-life का क्या concept था कि if the reaction, वो भी discuss कर लेते हैं just for revision, कि you can figure out the three half-lives that you need to know. One is if the concentration of a reactant decreases non-stop with respect to time and its speed is unaffected. This is called order zero. Order zero means that the half-life continuously decreases or becomes half of the previous one. So this is order zero. That the rate is unaffected. The gradient of the change that's happening is rate, and that remains completely unaffected. So that's order zero. Order one में क्या होता है? You have a graph. Now in order one, the rate would slow down. If the reactant concentration decreases, the rate slows down. So if you're starting at this point, the half-life remains constant. Every time it takes the same amount of time to decrease by half. And as a result, you start getting this. So as a result, you start getting this curve. In the reaction, the gradient keeps slowing down with respect to time. Because the reaction keeps on slowing down. And the third one is if it's order two. Now, order two, what happens is the reactants concentration are too dependent on the rate is dependent on reactant concentration, but a lot. It's a squared relationship. Okay, if the reactant concentration is halved, the rate would become 1/4. This what happens is the reaction slows down very quickly if the reactant concentration decreases. Like the first half takes, let's say, this much amount. The second time it takes to be halved again would be double the time. Third time it's going to be even double the previous time. Fourth time it's going to be even. So the reaction slows down very, very quickly. And so this is how the graph would look like. It would just keep on slowing down very, very quickly. And every half-life is going to be double the previous half-life. Because if the reactant concentration drops, the rate of the reaction or the speed of the reaction drops by a much bigger margin, which is why it takes more and more time for the concentration to decrease. The reaction just slows down very, very quickly. So the time keeps on increasing. So remember these three graphs of half-lives. Order zero would be that the concentration, the rate at which it decreases, it remains unaffected. Uh, Usually, this is not how reactions happen. Usually, if you see reactions, they slow down gradually. They don't just all of a sudden happen at the same speed. Uh, but this is order zero if the reactant concentration doesn't really matter. Normally, it's order one that if the reactant concentration drops, the rate also slows down. So it takes a longer and longer time. But over here, the half life is constant. But over here, in order to, the time keeps on doubling. And that's why the reaction slows down by a lot bigger margin compared to the drop in the reactant concentration. So, ठीक है, is this clear?
Yes, sir.
Next one is NO acts as a catalyst in the oxidation of atmospheric sulfur dioxide. State two equations. You should know how NO plays a role in acid rain. So acid rain की the two equations. One is that is he talking about NO actually or NO2? As the first thing is NO gets oxidized in air to form NO2, and then that NO2 reacts with sulfur dioxide. It oxidizes it to SO3, and the NO concentration drops to sorry, not doesn't drop. It's the NO gets reduced. explain why NO can be described as a catalyst in this reaction because it remains unchanged. Okay, this is the equation for acid rain. Remember this equation, and it remains unchanged. Describe with the aid of an equation environmental consequences of oxidation of sulfur dioxide. H2SO4 is going to be formed when it reacts with water. The environmental consequences is that the soil and water bodies are going to become acidic. So, TK, we've already done this question. We're going to do another question, TK, another paper next time then. TK, this paper is complete. So, आज वैसे I'm cutting. I have problems with my digital pen. It's not working properly. तो कल फिर क्लास रखते हैं. Okay then,
Okay,
take care.
sir. Allah.
Allah Hafiz.